Hello class, and welcome to Note 6.1, Equations in Two Variables. Our California Standard is AF 4.2. Our objective today is to solve multi-step problems involving two variables. And for vocabulary, we have a solution of an equation in two variables. It's an ordered pair whose coordinates make the equation true. Remember, an ordered pair is written as parenthesis x, comma, y, close parenthesis. The x is always first. If you ever switch the order, it will change the entire answer and make it incorrect, so be very careful. Teacher example 1. Tell whether the ordered pair is a solution of the equation. What's happened here is that someone has already solved the equation and you're doing the check. So if we go back here, and we can actually copy this. And bring it over here just to remind ourselves. We can put it right there to remember that x goes with 7 and y goes with -6. So we're going to go ahead and plug those numbers in. Remember, make sure you put the 7 in for the x, not the y. Now we want to go ahead, and all we're doing here is the check to see if all of this really does equal 14. So you can draw your fence, bring all the 14s down. They're going to come straight down. Of course, we're using order of operations, so we start with 3 times -6. And then 7, positive plus a negative, will give us secretly subtracting. And of course, because 18 has a greater absolute value, our answer is negative. -11 does not equal 14, so our answer would be no. Now we can go ahead and check this one here. Plug the -5 in for x, the 4 in for the y. Multiply. Now, of course, we can't subtract when working with negatives, so we'd skip change. -20 plus -8 is, of course, -28. So our answer here is yes. So what I'd like you to do is go ahead and do these 4 problems, doing the check. Plug them in. Be careful. Make sure the first number you plug in is always the x. This second one is the y. Go ahead and do them on your own. Press play when you're ready to see the results. Okay. Let's go ahead and see how you did. Plug in your numbers in, multiply, subtract, and you'll find out that no, 5 does not equal 11. Problem number 2. Plug your numbers in, multiply, skip, change, and add, and you'll find out that yes, the problem 12 does equal. Okay, let's continue on down to number 3. Number 3, you needed to plug 3 in for the x and -3 in for the y. Multiply. Add, which of course means you're secretly subtracting, and of course our answer is yes. Problem 4, plug in -2 for the x and 3 for the y. Multiply. Now notice it says subtract, but we know we have to skip, change, and we end up with yes. Okay, hopefully you got all of those right. Let's take a look at teacher example 2. Solve the equation for x plus y equals 15 for y. Then list 3 solutions. So when they say solve for y, they mean get y by itself. So if we take a look at the equation, we can see that the 4x is on the same side of the fence as the y. Okay, if I were to draw my fence right here. So if I subtract 4x from both sides, it'll move the whole thing. Now notice I want to subtract because I'm always looking at the relationship between whatever I'm moving and that variable, in this case y. So I can see there's addition right here, so I'm going to subtract it. And I can either write it as 15 minus 4x or -4x plus 15. Either way means the same thing, because if I skip change, I've got addition, and then I can put it in either order. You will see more often it's written with the variable first and the constant at the end, and that's just preparing you for when we get into graphing. Okay, now it said the next part says to list 3 solutions. So what you need to choose is you need to choose some values for x. My rule is you always have to use a positive, a negative, and then 0. So the easiest ones would be -1, 0, and +1. So instead of x, I'm going to write -1. I'm going to multiply. Then I'll have 15 minus -4. Same thing, of course, as 15 plus 4. You end up with y equals 19. So that means when x is -1, y is 19. So my solution is written as an ordered pair. When I use 0, of course, I love using 0 because it makes it nice and easy. 15 minus 0, of course, is 15. So my ordered pair is 0, 15. And when I use 1, 4 times 1 is 4, 15 minus 4 is 11. So my ordered pair is 1, 11. Okay, so I'd like you to go ahead and do the same thing. List 3 solutions for, first, this equation. Notice they've already solved for y, so you're just going to plug them in. On number 6, you first need to solve for y, which means you need to move this 3x. Then you can use these. Please use the values for x that I gave you and find your solutions. Okay, let's see how you did. Plug in -1, 0, and 1. You're going to multiply first and then add 6, and you'll end up with 8, 6, and 4. So my ordered pairs would be -1, 19, 0, 15, and 1, 11. Okay, here I'm going to subtract 3x from both sides, and I'll either have y equals -3x plus 4 or y equals 4 minus 3x. Remember, they mean the same thing. Now I want to choose my values for x and plug them in. And then, of course, I'm going to do my multiplication and add 4. And I end up with 3 ordered pairs, -1, 7, 0, 4, and 1, 1. Okay, please go ahead and go on to our quiz. The first 2 questions, it says, tell whether the ordered pair is a solution of the equation. So your answers are simply yes or no. On number 3, it says list the solution of the equation if x equals -2. So I want you to plug in -2 for x and solve for y. Your solution is, of course, always an ordered pair, just like this is up here. Okay, have a great day.